This is a video for the Inequalities and Absolute Values module. In this video we are looking at sections Ieab, A and B. Firstly, let's look at the objectives of the Inequalities and Absolute Values module. They are to solve linear inequalities, solve compound inequalities, graph linear inequalities, solve absolute value equations and inequalities, and to graph absolute value functions. Now, the definition of an inequality. Well, equations are mathematical expressions joined by equal signs. So in a SAL module that you should have just completed, we were dealing with equations. Here we're looking at inequalities, and they're mathematical expressions linked by one of the inequality symbols. And what are the inequality symbols? We have a less than symbol, a greater than symbol, a less than and equal to symbol, or a greater than or equal to symbol. Now, to remember which symbol is which, if I have a less than symbol like this one here, the smaller part of the symbol is on that side. So that's where the smaller thing goes. So if I have a number 2 on here, that has to be smaller than whatever's on this side. So I could have 5 over here. 2 is less than 5. Okay, in contrast, if I had a greater than sign, on this side, it's a bigger part of the symbol. So whatever's on this side has to be greater than what's on this side. Now, just some examples of the difference between equations and inequations. In this column we have equations, and you can see there's equal signs in it. In contrast, we have inequations in this column, and they have inequality signs. Now, linear inequalities contain only variables raised to the power of 1. So the key is that they're linear. Just like linear equations only contain variables raised to the power of 1. So in the first column here, I have linear inequalities. They're linear because all the variables have a power of 1. Okay, we don't write that power of 1, it's assumed. In contrast, other inequalities, we can look here, we have an x squared, x cubed, x squared. Here the power is actually with an x in it. The simple inequalities contain only one inequality symbol. So we have expressions or values on either side of that symbol. So we essentially have two parts. In contrast, compound inequalities contain two inequality symbols. So there's essentially 3 parts of the expression or value. So if we look here in this column, we have simple inequalities. So we have only one inequality, and that is separating into 2 parts. So we have 2 expressions on either side. Here we have 1 part, 2 parts, and we have only one inequality. In contrast, for compound inequalities, we look at the first one here, we have 1 part, 2 parts, 3 parts. And the reason why we have 3 parts is that there are 2 inequalities. Okay, same with the next one. 1 part, 2 parts, 3 parts, and 2 inequalities. Now, whereas a solution of a linear equation gives one possible value for the unknown variable, solving linear inequalities results in a range of values. Now, a solution may be all numbers less than or equal to a determined value n. So if I have x is less than n, to put that on a number line, n is any number. So just pick a point where I want it. X can't equal n, it is less than n. So I'm going to put an open circle, meaning that n is not included. But x can be anything less than it. So it's that side there. Okay, so an open circle means the value is not included. If I have x is less than and equal to n, okay, and n can be any number, so it doesn't matter where I put it on the number line. Now x can also be n. It can be less than or equal to, so I colour my circle in, and it's anything less than it, so on that side. So a closed circle means value is included. Okay, so for open circles we're going to be dealing with less than or greater than signs. For closed circles we're going to be dealing with less than and equal to or greater than equal to signs. Another possibility is that all numbers are greater than or equal to a value n. So for x is greater than n, put n anywhere on the number line. Greater than but not equal to, so I have an open circle, and n can be anything on that side. Next, x is sorry about that. X is greater and equal to n, so I put an n anywhere on my number line, and it's greater than or equal to, so I colour in my circle, and it can be anything on that side. Probably a ruler would be preferable. We could also have that all numbers between or equal to two values, m and m. So here m is less than x, which is less than n. So essentially this is saying m is also less than n. So if I want to put these values on my number line, I just have to remember m has to come before n because it's less than. Okay, it doesn't matter where they are, they're any numbers. It's only less than and not greater than, so sorry, it's only less than, not less than and equal to, so they're open circles. And x can be anything between those two values. In the next one we have m is less than and equal to x, which is less than and equal to m. So again, m is less than n, and it is less than and equal to, so I colour in, and it can be anything in between. We can also have a combination of less than or less than and equal to symbols. So here I've got m is less than x, which is less than and equal to n. So if I put my m and my n, m is less than x but not equal to, so I open circle. X can also be n. X is less than or equal to n, so that's coloured in, and then it's anything in between. For the next one, m is less than and equal to x or less than n, so I put my m, my n, can be x, so I colour in. This one's just a less than, so it's open. Okay. The other option is that it can be numbers outside or equal to two values, m and n. So x is less than m, or x is greater than n. Okay? So if I have m here and n here, x can be less than m, or it can be greater than n. Okay, I know that the m and n has to go that way, because if I had n here and m here, I'd have n was greater than and then less than m, so that wouldn't be written in the same way. We would write that n is less than x, which is less than m, and that's not what we're starting with. For the next one, x is less than and equal to m, x is greater than n. So for my values on my number line, m and n, x is less than or equal to m, so it's coloured in. X is greater than n, so it's open. So here are some examples. It says graph the solutions to the following inequalities. So the first one is x is less than 3. So I just put my numbers on my number line, so it doesn't matter which way I start. So if I go -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. Okay, x is less than 3, so I put an open circle, and it can be anything down that way. Okay, x is greater than or equal to, so we know it's going to be a closed circle. -2. Try and put your value that you're using, so here, in the middle. So if I put -2 there, -1, 0, 1, 2, 3, 4, -3, -4, -5, -6. Okay, so colour in at -2 and x can be greater than or equal to it. The next one, we have a combination. So I need to make sure both of these values fit on the number line. So I put -2 here, -1, 0, 1, 2, 3, 4, 5, 6, -3, -4. So I have an open circle and a closed circle. So an open circle at -2, a closed circle at 3, and it's anything in between. Here I have x is less than 0, x is greater than equal to 2. So let's put 0 here. 1, 2, 3, 4, 5, 6, 7, -1, -2, -3. So x is less than, so that's an open circle, or greater than equal to 2, closed circle. So when an open circle at 0, x can be anything less than it, closed circle at 2, and it can be anything greater than it. What do you do now? Well, you need to complete the exercise Ieab B1 from the textbook. Make sure you understand what you're doing, and if you have any questions, please contact your course advisor.